So in section 2.5, we are looking at matrix factorization. And in particular here, we're being introduced to what is known as the LU factorization. So the LU factorization of a matrix A is motivated by the problem of solving a sequence of equations, all with the same coefficient matrix. So in other words, the matrix A times vector x equals vector b sub 1, matrix A times vector x equals vector b sub 2, and so forth and so on, all the way up to our last matrix equation, matrix A times vector x equals vector b sub p. So we want to solve this sequence of equations simultaneously. So to begin this process, we want to start by assuming that matrix A is an m by m matrix that can be row reduced to echelon form. And we want to note here that these row operations are without row interchanging or row swapping. So the way that the row operations work is that each of the elementary matrices represents a row operation that is a lower triangular matrix. So by swapping a row, the sequence of inverse elementary matrices performed is no longer in lower triangular form. So we would need to multiply by a permutation matrix. So we are going to avoid interchanging of rows here. So assuming A is n by n, then A can be written in the form of an LU factorization defined as matrix A is equal to matrix L times matrix U, and this is where L is an m by m lower triangular matrix, and this is with ones along the main diagonal. We also want to make a little love note here to ourselves that L is invertible or singular. And then we also have that matrix U is an m by n upper triangular matrix. And this is in echelon form.